Hi, thanks for joining us at the Rocky Mountain Angular. We're going to talk about observables tonight, and Angular2. So I'm Geoff Filippi, and I'm going to skip the introduction. Skip too far. Okay, so tonight we're going to cover some of the fundamentals of Rx and observables, and we're going to talk about some related concepts, and then we're going to talk about how that applies to Angular2. So I think it's really important to have like a brief overview of reactive and reactive fundamentals and talk about reactive programming, really briefly about FRP, and talk about the underlying observer design pattern. So you might have heard of this feature that was proposed of JavaScript. It's since been abandoned, but it was called Object.observe, and so that's not the same as observables, and that confuses a lot of people, but we'll get into that. Observables are also related to promises, which you probably use, and they're already part of the ES 2016 spec, and they're already running in most browsers already. And some other async concepts like promises. And the underlying implementation of observables that we're using in Angular2 is RxJS, so we'll talk about that. So in Angular2, you're going to use observables and things like forms. So your forms will be observable and their fields will be observable. You're also going to use them for HTTP calls, so when you're making an asynchronous call to a web service. And there's also a new feature called Async Pipe, which you can use to kind of filter in these streams into your app. So with that, we'll talk about the fundamentals. So reactive programming is really mostly about data flows, like how does data flow through your application or through your system. And it has a lot to do with propagation of change. So if you're used to Angular 1, it had a change detection system. A lot of different frameworks do have one, but the change detection system in Angular 2 is completely reworked, and it's all based on observables. So what's reactive? If you really want to get down to it, there's this thing called the Reactive Manifesto, and I definitely encourage you to take a look at that. But we're talking about systems that are responsive and not like they don't change shape like CSS, but they respond to the user. So when the user clicks, something happens. They're resilient, so if something goes wrong, they still work. Maybe they don't work as well, or maybe they don't do what they did before, but they still work reasonably. Is there a question?
I'm curious, is it just a play on words, or is there any real difference between event-driven programming and reactive?
Yeah, so definitely event-driven programming was the question was, is that the same as reactive? They're not the same, but they are related. And I think the thing that's different about reactive than event-driven is talking about streams and how events are individual occurrences, but streams are events that happen one after the other, maybe just a few, maybe forever, right? And so I think events one after the other it's a lot like, and we're going to get into this, what's the difference between a promise and an observable? So I think you can make the same analogy between what's the difference between event-based and reactive. So,
so it's a stream of events.
Stream of events is, or a stream of anything, but events is very typical for a reactive system. It also means that a reactive manifesto also says that applications systems that are reactive should be elastic. That means like if 5 people are using the site, that should be fine. If 5 million people are using the site, that should also be fine. You should be able to respond to your customers' peaks and valleys of usage and things like that. So and that doesn't mean that you can handle unlimited usage, but it means that it should degrade in a very predictable way as the usage goes crazy. And if you do it right, you can deal with lots of usage, but that's not necessarily the full scope of reactive. But it's also that reactive systems are message driven. So the unit of a reactive is like an event or a message, and those systems are based around messages as a unit. So we'll talk about that. This is a kind of an overloaded term, and a lot of people, especially the functional reactive people, it means something very specific, and there is academic, publications behind it. But for people that use it as a job and are not in academics, I think the best way to think about it is it's a combination of the two techniques of reactive programming combined with functional programming. And whether you know it or not, or whether you think about it that often, JavaScript is a functional language. So it may not be, it's not as functional or maybe as pure functional as something like Haskell, but at its root, it is functional. And it has things beyond function, like the object-oriented parts of it. But whatever you need to do in a functional language, a lot of it is in JavaScript. And if you're not thinking of it that way, maybe it's time to think of it that way. So some of the concepts that are important for observables is this observer design pattern. So this is from the Gang of Four. It's a Java book about Java patterns, but it applies to other languages. I think it's really applies best to Java because it does talk about certain specific things that the Java language kind of either provides or limits you with. But what we mean here is that the subject tracks an observer, and the subject notifies observers of state changes. So there's this relationship between subjects and observers and how they pass messages to each other. And I think it's really good to, and you'll see these terminologies mixed up, but for most purposes, you can think of a subject, observer, and a producer as the same concept, and just different words for the same concept. In a similar way, the observer and the consumer are similar words for the same concept. So don't get confused when you see those being used all over the place. This is one thing I wanted to cover because if you followed JavaScript, there was a proposal called Object.observe, and that's not the same as observables. And that proposal was withdrawn. It did get to stage 2. I think there's a good lesson there. It's like just because the thing you're interested in is at stage 1, that doesn't mean it's going to be in the language. Like it may or may not make it. And that's why we have stages, so that we can vet things out and see if they're good ideas. And if they're not good ideas or a better idea comes along, they may not make it. But it does give some rigor behind. When we add stuff into JavaScript, you may not agree with what gets added or not, but at least the community's had a good long chance to talk about it. And there is a proposal called Proxy, which you could implement a similar thing with. So I'm not going to get too much into proxies, but some of the criticisms of Object.observe, and one of the reasons that it didn't move forward, it required big changes to the object internals. So JavaScript is an object-oriented language, and when you have to go about changing object in JavaScript, that's not a small thing to ask, right? So that was kind of a red flag right away. Also, there was never really a proposal that was convincingly that would not have bad performance. So all the proposals that came around, they looked like they were going to have really bad performance, and a lot of the early implementations and trials were really bad. So, and it wasn't really well supported or adopted for some of those reasons, but really what happened, I think, really to it was observables, and something like observables came along and kind of eliminated the need for it. And RxJS and things like that had a lot to do with that. Because when people are looking at what Object.observe does, they're like, well, why can't we just do that in a library? Why do we have to muck with the internals of JavaScript to make that happen? So that's why, among those reasons, is the reasons why it was abandoned. So observable is a current stage 1 proposal, and that means it's a fairly early proposal. But it does have a description and specification. And the only thing that's really important about that for you to know is that RxJS 5 was written and rewritten. It was actually rewritten to match the specification. So whereas RX4, which a lot of people still use, especially in other frameworks, it has nothing specific to do with the specification. So the specification is a little bit more detailed than RX4, and RX5 is what we use in Angular2. So some of the differences between observables and Object.observe. are that, so what we've done with observables and what Rx does is essentially creates like a wrapper around your object instead of actually modifying the object internals. Whereas Object.observe required the JavaScript engine to modify the internals of the object. And what it did was, what it was planning to do was, if when any property on your object changed, it was going to have an eventing system built into the JavaScript engine. But what Observables does is it just puts an object kind of around the object that you care about, and it also allows you to subscribe and unsubscribe. So it's a lot more lightweight. It's a lot less intrusive to the language and to the runtime, but it does a lot of the same things. So we'll talk about what those things are. But that's the kind of the key difference is that instead of going around and mucking with the engine and the objects itself, it actually just provides a simple wrapper model. So this is the hard way to create an observable, and I'm just giving it here for an example, but it does kind of show you the shape of an observable. So you can new up an observable, and then you can pass the thing that you want to observe. And you can also have, so you can say, well, if I've got an error, so you can have an error handler and things like that. You can also have, what do I do if I don't have an error, and how do I complete it? And you can also have a return. What is on each iteration, what does it return? So this is not the way to actually do it in practice, but this is how you would do it, kind of the manual way. But fortunately, we have things like RxJS, which has much more convenient ways of creating an observable. And so we'll look at those. Is there a question? So yeah, I wanted to get into to compare some things that you're familiar with and some things that you're not, maybe. But I want especially observables, promises, events, and callbacks. So if you've been doing JavaScript, you probably have been exposed at least to promises, events, and callbacks. So what's the difference between a promise and observable? And this is very similar to the question that was asked about events, right? So a promise is like an async variable. So something that you're going to get back later, right? But an observable is a lot more like an async array. And it's different in the sense that it's not an array in the memory, it's an array over time. So an observable is like a bunch of promises that are strung together in the same way that an array is like a bunch of values kind of strung together. So.
One other quick question there. So the promise, that's a single instance, perhaps, or is it observable? It's multiple instances, and you're continually going to receive messages anytime.
So yeah, the question was, is a promise is a single occurrence? And I think the way I would say it is, a promise is something that happens and it's over. So one thing, right? Like one event, if you like, or one, like I make an HTTP call, I get an answer back, and it's over. The promise is at that point completed, right? But an observable is like I want to listen on, and it could also be on HTTP, but I want to listen for any number of responses, and I'm going to take as many as come in, and I'm going to deal with them. So I think that's the big difference between promises and observables.
Think about it like it's a string.
It is like, yeah, for sure. Like you'll definitely, when you want to talk about observables, you're talking about a stream, right? And so I think that's the big thing about the reactive, the whole reactive concept or reactive manifesto is we're going from talking about things that are asynchronous and they happen once, like fire once, and forget or whatever, to things that happen over and over and over again. And they may never end or they may end, and we have ways of dealing with both situations.
So, publisher, subscriber?
Yeah, and that's, I think, the pub sub or publisher subscriber, that's what we were talking about, the observer pattern, right? These are things that I emit events or and I'm going to send them out, and something's going to listen to me, and it's going to deal with it until it doesn't want to deal with it anymore, and then it can unsubscribe. And if everybody's unsubscribed for me, I'll actually stop. I'll notice that, and I'll say, well, no one cares. I'm not going to send any events out. But when someone starts subscribing, I'll start sending them out again. So, but contrast with a promise, which is kind of a limitation of promises, and one of the reasons that observables are needed is that really if you want to have if you want to implement something like a stream and promises, you actually need a promise for every single event. And that can get pretty clunky. And we'll look at some of that too. Okay. So another way to, and this kind of gets into more detail, but essentially what we're talking about, a promise is a single value. It cannot be canceled. So once it's created, it's going to complete one way or the other. It's also not lazy. So once it's instantiated, it actually starts doing work immediately, which is fine for some things, but not always. And it can be good. Like an example is it's good for AJAX calls, but not if you want to cancel them. So like, for instance, if you make a promise and the user navigates away, well, that code's still going to have to run when that promise comes back. And we'll contrast that with observables. But promises also do allow you to have catch and finalies. So you're able to clean up errors and completions. Observables, on the other hand, are streams. And they can be unsubscribed. So effectively, they can be canceled. They're also lazy. So you can create an observable and nothing happens, nothing executes until you .subscribe. So that's a good way to like create this pipeline, and you're not putting any stream through it, but once you want to, you hit subscribe, and that's when that logic starts. So and until something flows through it, there's no actual code being run. So so those are kind of the two things that are important differences. And people that use observables or fans would say that it's better for events. So if you think of like WebSockets, WebSocket, you might get a stream of mouse movements or a stream of keys. Those are things that with promises, you'd actually have to have one per keystroke or one per mouse movement. It's just a lot more convenient in a stream. And then on animations, it's not uncommon in an animation to want to cancel it because somebody's clicked a button which effectively should cancel your animation. So observables make that really trivial. So definitely you want to look at that for animations. Also, observables are really easy to retry. Whereas with a promise, if you want to retry, you have to create a new promise. And they also do have the catch and finally block. So you can handle errors and completions as well. So I think before I move on, I want to see if anybody has any questions about the difference between observables and promises. David?
This be more for like, I guess like a feed or like a polling or something?
Yeah.
You constantly want to be checking on something rather than just like getting one response or just constantly polling the server.
Yeah, so the question was like, would you use this for a feed? Absolutely. You would definitely use it for feeds, like WebSockets, chat rooms, chat functions. These are the kind of features that observables are really strong at. So compared to promises, which they're also, we've been using them for years, and they're actually, you could definitely consider them a great improvement or nicer syntax than callbacks, some people would say. And it's also, especially when you need to, like with a promise, when you need to coordinate a couple different things that would have been callbacks. So if you need A and B to come back so that you can compute something for C, then that's where promises are strong. But I think as we'll see, observables actually handle that pretty nicely too. And they have these other advantages. So.
Yeah, if you go to Angular2's website, you can see like on their Heroes tutorial, they're using it in a search function where it's like autofilling, like search query recommendations, kind of like Google. When you start typing something in, it autofills.
Yeah. So we'll talk about the type ahead, which is what basically that feature that was being described there. So type ahead is a really good use of observables. Matt.
So this is better for animations. Does this have like animation keyframes built into it?
No, I mean you still have to build that yourself, or you can use like Angular's Animate or whatever your framework's animations are. But what it's really good at is like you might want to say, well, I want to animate to this point, and when that animation's done, I want to do something further, and I might want to string a sequence together, and that's pretty easy to do, relatively easy to do with observable. But also you want to be able to cancel at any point. right? So like, if may have got animation sequence, but like when the user clicks a button, I want to cancel the whole thing. That's really easy to do again with observables. Versus a promise, like if you did an animation and a promise, you would essentially have to run it. You might have to do like a trick like hiding it while it's running, but it's still running because you actually don't have the option to cancel it. There is a proposal to make cancelable promises, which I think is a good idea for sure. If you're going to have a promise, it'd be sensible to have a way to cancel it. But currently we don't.
A huge application for observables right now is these real-time databases like Firebase and Realm. I'm using observables with Firebase and Angular2 right now, and it's really great. Like you said, you can pipe to async, and it's an array over time. So as the data propagates from a single point of truth to all the clients automatically, like you don't need to worry about changing data on your data source. So it's just kind of like an observable stream that you can feed into and follow, print out, like ngRepeat almost.
Yeah, so if you didn't hear that for the camera, there's a thing called Firebase, and there's other reactive backends, and using RxJS on the front end, you can actually tie into like Rx Java or Rx other versions of Rx, and Firebase is one of those where basically you can have an object in a database, which when it's changed will create a stream, and basically it'll stream out the changes. And so you can have your app just listen to that stream of changes. And you don't really have to make a call or poll or any of that stuff. You can just say, well, I'm going to observe this object in the database, and when it changes, it'll update my app. And we'll show how you pass observable changes into your app using the async pipe and things like that. So it's a pretty powerful concept, and I think you'll, something you want to look into if you have a streaming or reactive type of backend. Yeah, the question was, can you throttle the observable? You can do throttling, and there's actually this group of things called operators, which we're going to look at. There's like probably too many, but there's like 30 or 40, 50 different things you can do in a stream that are already written, and you can write your own too. So we'll talk about throttling, debouncing, retrying. There's like a whole number of different operations that are things that you commonly do, but they're really clunky. Like think about how would you throttle a promise, or how would you retry a promise? It's actually a pretty big mess. And if you want to do it right, it's pretty difficult, but it's a lot easier when you're talking about streams. So we'll look at those things. Okay, so I showed you like earlier the hard way to get an observable, and like probably thinking, well, okay, well I know the hard way. Well, what's the easy way? The easy way to get an observable is to take something that's already asynchronous and just throw a helper on it. So I can take a promise, and I can do, and from RxJS, I can do .from, and that'll give me an observable on that promise. I could take a generator. I don't know if anyone's used generators, but you can actually turn a generator into an observable. Obviously, most of us use callbacks, so you can take a callback and turn it into an observable with the from callback. And there's a couple others here. Events. So if you're listening to something on the DOM, mouse click, keyboard, you can actually do a from event on that and get a stream out of that. So anytime that DOM element issues an event, you'll be able to track that. So Ajax and WebSockets, those are other things that are really easy. So like if you have a WebSocket, you can just call from WebSocket on it, and you'll automatically have an observable. It's probably worth knowing if you've ever used like Bacon.js or Kiefer.js. These are other implementations of observables, and you can actually get an RxJS observable from them. So you can interoperate with other observable JavaScript libraries if you happen to use them. So, and these are definitely the recommended way to create observables. Actually, you can even do non-asynchronous things and turn them into an observable with a helper. So you can actually take an array, which is already in memory, and you can make it look like an observable. And that just makes things like, and it's also helpful like if you want to interleave it with something that actually is a stream. So you can turn these things that are in memory into a stream if that's convenient for you. And in some cases that would be. Especially like in a test situation, you might want to mock out an observable with an array instead of having to worry about all that. So you can actually create an array of what you think the observable test case you want to make is, and then just create call .of on it, and then you have an observable, and you can pass that to your function, and the function should work the same. So you don't have to like have it's a lot easier to write tests around observables if you use something like that. But there's also other things you want to do that in your application as well. So if you're familiar with promises, I think the easiest way to think about it is everything where you have then, it's now going to be like .subscribe. So it's a little bit more, there's more to it than that, but I think that's the right way to think about it. So another difference when you're actually trying to work with promises versus observables, promises always complete. They're either going to succeed or they're going to fail, right? Observables don't need to complete. They could run the entire time your app's running. So you start your app on Monday and leave it up until Friday, and your observable could be running the entire time. And if you shut your browser down, then it stops. But if you need to do something when an observable completes, you're going to have the option of having a completion handler, and we'll look at that. So when I wrote this, RxJS was in beta 12, and I think it still is. But let's check. Make sure. Yeah, another tip, if you're Googling or whatever, make sure you look for RxJS 5, because there's a really popular library called RxJS 4. Same concept, but it's different. It's a different specification, so it's going to work differently. And it's also really important when you're looking up documentation. Make sure you're looking up documentation for RX5, or some things will work differently. It's not huge, but it'll definitely trip you up when you're trying to learn it. And we're in beta 12 still. So actually, I think I updated this slide if I'm not mistaken. But so RxJS is a specific implementation of observables, and it's implemented according to the spec. What it provides is the observable. It also provides the subject, and we'll see what else, the other but those are the key things that are provided in RxJS, and it's the same implementation that's used in Angular2. So when we look back at that code that we're looking at, RxJS beta 6 is what, when I generated this app, that's what it was using, but I think Angular2 uses 12 now. But, okay. So, with that, we'll go into how this works in Angular2. So in Angular2, we're going to be using this in forms. So when your form element changes, somebody starts typing, you're going to get you can observe an observable of that form element, and you'll be able to do things based on the changes. Also, when you make an HTTP call, there's more than one way to do it, but in Angular2, you're going to be able to do it with an observable. Also, this thing we talked about a couple times called async pipe. But interestingly, the entire change detection system of Angular itself is implemented with RxJS and observables. And that's one of the reasons why it's dramatically faster than it was in Angular 1. So, because basically changes to your app are also streams. So let's take a look at forms. So forms are observable. So say we have this form, with an SKU element, and then we can actually here create, this is all built into Angular, which makes it really nice. So I can take my SKU element of my form, and I can actually subscribe to value changes because it's already an observable. And I didn't have to write code for that. That's just me saying, okay, and here's where I'm going to handle when that changes. So all of this, the fact that your form is a observable is already part of the framework. And obviously you can do this in other frameworks but you might have to make them an observable. But here I can say that when I get an event coming out of the stream, then I'm going to log that out, and I'm going to say that, well, that SKU just changed, and here's what it changed to. And this is the basically the handler of an observable. So when you do a subscribe, you're going to have in the subscribe function a handler function, and this is the fat arrow syntax. But essentially, I'm taking the value that changed and I'm passing it to this anonymous function or lambda that I've created here. And Same thing with the form itself. So you can subscribe to an element, but you can also subscribe to the entire form. So when anything changes, I can have a different handler for that. And that just looks like this. So I'll take that same value and log that out. So this is a really great way to respond to form changes in Angular. And it's going to make it really nice.
So you have an event subscribes, but then that stream will stay open until you fire them.
Yeah. That's right. So once the question was like, well, you subscribe to it, does that event stay open until you unsubscribe? And it does. So anytime this form changes, this listener is fired until you unsubscribe. And also, if you can, I don't think it really applies to forms, but just to kind of drive the point home, if you have an observable, you can also complete it. So in forms, maybe on the submit, you might complete it. So also, we talked about how you would use this to make HTTP calls. So obviously, you can still call HTTP calls with a promise, but now you're able to, calling them with observable, you're going to be able to cancel the results. You're also going to be able to stream results as they come in, because they may not all come in at once. And this is kind of what we're talking about, the type ahead, right? So if I've got a Google box and I'm typing, and I type a couple characters and I want to go and make an asynchronous call, I can actually, instead of making one promise for each call, I can actually stream those HTTP calls out to my service, and I can stream the results back in, and I can handle them however I see fit. So one of the things that, if you've ever implemented type ahead, is really hard to do with promises, because you are not guaranteed that, maybe I type 2 characters and I made a call, and then I type a 3rd character and I make another call. You might get the callback for the 3rd character typing before you get the callback for the 2nd character typing, and then later you'll get the one for the 2nd character typed. And you have to handle that, or what might happen is you might type 4 characters or 5 characters, and you might get matches that have more to do with the first 2 characters. So you're actually, the more you type, it can actually seem like the results are getting worse, and then they get better and they get worse. So you really have, and also, when you stop typing, you might want to cancel, or if you click on a result, you might want to cancel, but you're really not able to with a promise. But with observable, you can. So you can unsubscribe immediately when the person clicks on the result, things like that. And HTTP calls used with observables are going to return an observable result set. And this is also good for, obviously, WebSockets and things like that, but it's also good for like repeated HTTP calls where you have different results coming back that you want to feed into a form or something like that, or into your results page. And this is what it looks like to do an HTTP call with an observable. So I'm using in Angular2 HTTP, and I can do a .get, and then so .get is a kind of basically a stream operator that you can do on that. Basically, what it's doing is it's taking your HTTP result, or so your HTTP request, and saying I want to make it a GET request, and then so at this point, nothing's actually happened, right? All we've done is saying I want my pipeline to be shaped like this. And then you could say, well, also, if I get an error, I want to retry, and I want to retry 3 times. Also, I want to take the result, and I want to get the text out of the result. And nothing's happened yet. All I'm doing is defining the shape of the pipe and what behavior I want to have. Now when I hit subscribe is when anything actually happens. And in the subscribe function, I'm saying, what do I do with the data? I'm setting it into my class, right? What do I do in the case of an error? I'm logging it out. And what do I do when it's completed? In this case, I'm logging out the fact that it completed. So this is really concise compared to how you would do this with promises, because you'd actually have to have 3 different promises created, and you'd have to coordinate them. And promise 1 fails, then in my failure handler, I'd have to create another promise. So that's the kind of thing that we're avoiding now. So I think it's a lot more for something like a retry. And there was a question earlier about toggling or throttling and debouncing. You can actually handle throttling in here too. We looked at the typehead example. If someone's typing really fast, maybe they're typing 20 characters per second, I don't want to make 20 queries. I only maybe want to make 2 queries or 1 query. So I could actually throttle it down to with an operator called debounce, I could actually say, well, I only want to make 1 per second. I don't care how fast I type, and that way it actually behaves a lot better and it'll scale better and you'll be able to handle more customers with it. And it still will do a pretty good job. And it actually might do a better job. So you can tune that stuff. So that's how HTTP works in Angular with observables. But pipes, okay, so pipes, we talked about, this is not yet async pipes, but there's a concept in Angular2 which you may have started using called pipes. And it's a lot like Angular1 filters. So you might use this if you want to take, for an example, you might want to take a decimal and you might want to put a local currency format on it. Like you put a $sign in front of it. If it's got more than 2 decimals, you might want to truncate and round, whatever you need to do. And you can do custom ones, but there's also ones provided by the application. So, the framework. But we also have this thing now that's new in Angular 2 called the async pipe, which didn't exist. But essentially what the async pipe does is it can subscribe to an observable. And so in this first line, I'm just creating an observable. So I did a timer async, and I'm creating a static observable, and I'm giving an interval operator. So I'm saying I want this to happen every second. And I'm also giving a starts with operator, saying I want it to start at 0. And that's all it takes to create an observable. And what this will do is every 1 second, it'll give you another value. It'll actually give you the timer. And so here's how you would use it in your Angular app. So I'm just going to have, kind of the mustache syntax or whatever. And I'm going to say this object timer async. And I'm going to tell Angular that by using the async pipe, that this value is going to change over time. And every time it changes, I want Angular, I want to notice, and I want to update my UI. And that's the entire code for this. Like there's really nothing else to it. You just have, basically if you drop this in your Angular app, you would have a timer that increments. And so you can take any observable object and put it in, mustache syntax or whatever, and then you can just put async pipe on the end of it. And every time that observable changes, it's going to update your UI automatically. And so this is something like that you would put in your template, right? So it's a very simple, straightforward way to get changes into your app. So I want to talk a little bit about how change detection was implemented in Angular 2. So your entire app is a reactive system now. And this is borrowed from things like Elm and React Redux, things like that, where the idea is that your entire app is this reactive system, and if something changes in the state, then your app should react to it or respond to it. The change detection is now strictly directional, so one directional. If you've used or looked at the banana in the box syntax, basically what you're doing is you're emulating bidirectional by setting up two unidirectional bindings. So, but by making Angular by default directional, it makes it very simple for it to detect that I don't need to go down to this change tree because the thing that changed isn't nothing in this tree knows about the thing that changed. So nothing in this tree will need to be redrawn. So it helps you skip walking parts of that DOM tree in your app tree. And you can actually make that better by using things like immutable objects. And if you use observables in your app directly, it'll help Angular skip parts of your app that don't need to be redrawn. So it's probably worth doing if you need to care. If you have an app where performance is an issue, or where you want to make sure it doesn't become an issue, to take a look at how the change detection system works. But it's new in Angular 2 and it's based on observables. So finally, this is kind of like a little side topic, but if anybody's used React or interested in it at all, there are reactive extensions for Angular 2. Essentially what they've done is they've taken RxJS and they've re-implemented Redux natively in Angular 2, and they call it NgRx store. And this lets you do like Elm style or Redux style apps in your Angular app. So you can do this today. It's already available. And there's definitely some Angular people, and some people that use React and Angular that are really interested in this. And it may, who knows, maybe one day this will be how we all write Angular apps. And if you think that way, you can certainly try it out. But it could just be that we use it for performance intensive things, or maybe we just use it if our team likes, we like the Redux style. So you can use Redux obviously in React, but you can also now use that same style or pattern in Angular2 if you like. So with that, I'll take any questions that people have. David?
Question. So for the async pipe in parentheses, was that like necessary for like highlighting reason, or did you just put that in there? Because I know usually in Angular you have the double squiggly brackets, but the async pipe, is that a new thing for Angular 2?
Yeah. Definitely. So the question was it was about the syntax, I think, right? So, this part here. Yeah, this part here is nothing but text. This could say anything, there's no significance to this text. The only thing that's significant, that's new, is this. So yeah, this is nothing but illustrative of what we're doing, right? Yeah. Sure.
Is there anything we should look out for in terms of memory leaks and unsubscribing?
Yeah, so the question was, is there anything like memory leaks where we should look at with unsubscribing? You can definitely create problems in your app if you subscribe to too many things, or if the things you're subscribing to have too many events. The good news about that is there are operators that you can use like debounce, which limit the number that you process. You can skip, you can sample. So just like anything, you can blow up your app with events or streams. And a lot of it depends on what do you do to the thing that you're subscribed to. But also, more to the point of the question, you can actually get yourself into a situation where you leak subscriptions. So like if you have logic that subscribes but never unsubscribes, it's maybe okay if it only does that occasionally. But if you've got that in a loop or something, you could definitely create, what would happen is you'd actually create a lot of subscriptions and a lot of events and a lot of, basically there'd be a lot of CPU activity on listening to all those things and having RxJS running through them all. So just like anything PubSub, this is actually a common problem with PubSub in general. When I subscribe to something, I need to make sure I unsubscribe from it when I'm done with it, if that's right for my app. So
One of the things that we've actually been seeing with this is that when we load a component, we're often doing subscriptions in the on a net. What happens is that it's cumulative. It keeps adding them. And so we'll start to see the same calls happening 4, 5, 6 times on the loading of a component. And so what we've actually started to do is implement on destroy, keeping track of those subscriptions, and then making sure that when you destroy that component, because the component's still going to be there. Think of it almost like a singleton. It's still loaded. It's the ngInit and the on a net and on destroy that allow you to create and then destroy those. So it's definitely something you need to watch out for.
So and for the camera, if you didn't hear what Jesse was saying, basically components have lifecycle hooks like ngInit and destroy. That's kind of where you want to handle those things. So like when your component loads, you might want to subscribe, and when it's destroyed, you might want to So use it with care, but definitely.
A lot of the examples I'm seeing online for Redux style Angular 2 apps are using immutable.js. Have you seen this? And is it necessary, or is it just with the unidirectional data binding, is it all immutable anyway?
Okay, so the question was about Redux style and immutable.js, and I'm not like a Redux expert or anything, but you can do Angular2 with Angular2 by default. You're mutating, right? So you're like when you have a property, you're changing the value of the existing property. The Redux style, if you choose to use that, or if you use React, the the way that the pattern's defined is you really should never change something that already exists. What you should do is create a new one with a new value. And then what you do is if you don't need the old one, you dispose of it. And so you can do, if you want to, so Redux is actually like a data flow pattern. So it's not necessarily a specific implementation, although there's the Redux library that goes with it. So if you want to live up to the Redux pattern, you really shouldn't be modifying your objects or state. You really should be creating new ones that maybe are copies of the original, then deleting the one. And things like Immutable.js help with that, because what you're trying to do is say, like, once I've created something, I never want to modify it again. And it helps you to do that. And that does have benefits in concurrency, right? So it lets multiple, basically it's a safer way to do lots of concurrent changes to something, because you don't have to worry about shared mutable. The big gotcha, right, is, and the reason why these things exist is this thing called shared mutable state. Like it's okay to mutate things, and it's okay to share things, but it's usually a bad idea to share the thing that's being mutated, because it may start out in one state and end up in another, and it may change in an inopportune moment, right? So what these things like Redux want to do is say, well, I'm not ever going to change something once I've initialized it with a value. And the thing that does mutate is my state tree, which is what RxStore is an implementation of. So it's basically a store of state. And that's the only thing that does change. And the way it changes is very regimented, which is like, I take the state of my application is in one one state, and I send it an action, and this thing called a transducer, thing called a reducer rather, changes it to makes a new one in the different state. So it actually creates a new tree in a different state. There's definitely some performance benefits to that, because if you do that, and you always only do that, then the application never needs to check for changes, because it knows I'm not allowed to change it, so therefore it's never changed. So that all of the checking for things, whether they change or not, kind of goes away. But it's not for free, right? Because you still have, effectively the state of your app has changed. It's just not the original object anymore. But it does make the change detection system very, very fast, right? But it's not for free, because what you're doing is you're trading memory, right? Because what I'm saying is, like, I'm taking an object, creating it, and throwing it away. Well, that took up memory, right? And when I throw it away, that means it has to be garbage collected. And garbage collection has performance impacts. So it's not totally for free, but in a really important way, it can make sure that your change detection system is very optimized. And so if you've got problems with your garbage collector, this isn't going to help. But if you've got problems with your change detection being slow, this would definitely help. So it depends on your app and what it does, but definitely it's not for free. But if you wanted to go in the route of immutable, then you do get really rapid change detection. So it's got those benefits. Any other questions?